In this scene, we're creating a candle flame and wispy smoke with XplosaFX. We'll turn our candle wick into an XplosaFX source and have it generate fuel and heat for our simulation. We'll then use various simulation controls and tag settings to change the look of our flame and generate wispy smoke. We'll create a burning effect using the xpVertexMap object, and finally animate and extinguish our flame. Okay, so we're going to be creating a candle flame and some wispy smoke to go with it. And of course we need our supporting props in our scene, and you can see we have those here. We have a wax candle on a brass holder, and then it has this wick piece of geometry up the top here as well. It's got viewport materials on. Now this is actually sat inside this XP system object, and you can see it's also within a null called Animation. And if I hit play, we'll actually see that our candle holder lifts up off the ground. It sort of sweeps around a little bit, and it comes back down to the ground, and then it actually spins back to its original position. Now what we're going to do here is we're going to have our flame coming off the wick, of course, where it should be on a candle, and then it's going to swoop around here, and then it's going to settle back down, and we'll be able to see that interesting look on the flame. And then when it spins back round, I'm actually going to extinguish the flame, and we're actually going to be reset at the beginning again, and we'll get this looping animation. So first of all, we're going to need to add a few things to our scene, and we already have an XplosaFX object here. It's just disabled. We can turn that back on, and of course we need it to encompass where we want our flame to be. Now I'm going to deal with just a static object to start with. So the animation null, I'm actually going to drag our candle and holder out. So when I scrub now, you can see that we get no movement, and I can hide that animation null, and we'll add that in later. But for now, I'm just going to start with a pretty small container, and I'm going to give it a height of 200, and I'm just going to put it above here like so. And of course our candle flame is going to rise. It's going to be buoyant, and often you'll have your containers with your source items in the lower part, as buoyancy will carry things up. I'm also going to change the voxel size. Now we're dealing with quite a lot of detail here. We want a really nice crisp flame, and we're going to start with a voxel size of 1. Okay, so everything else about that XplosaFX container is default. And let's go and zoom in to our wick on our candle here. Now this needs to be, this is quite a high res piece of geometry. And if we actually view the polygons and I select them all, you can see as I zoom in, you can see it's actually a very dense object. And over here we have this readout, which is telling us that it's 120,000 polygons. Now that would be a heavy mesh to have as a source. So what we're going to do is we're going to create a proxy for this wick object. And we want to create a proxy that's going to encompass the wick. It's going to have enough geometry that we can emulate the shape of our wick, but it doesn't need to be anywhere near as high resolution. So we'll grab an open VDB mesher. So I'm going to bring that up on our generators tab over here. Let's grab our open VDB mesher. And then I'm going to link up this wick geometry. So I'm just going to drag that in there like so. And at default, you'll actually see that we don't get anything, and that's because the resolution of our default OVDB mesher is larger than our wick here. Now our wick is about 1.5 units in diameter, and if I hide it for now, you'll see we do have a tiny piece of geometry being generated, but it's barely anything, so we need to increase the resolution of our OVDB mesher. Now this is also voxels, and if I drop it down to 2, you'll see we start to get more. And then I know that I need to go down as low as 0.5 here. And you can see now we have this approximation of our wick. And if we view that in a wireframe, in fact, if I go to the display, change our display to quick shading and lines. And as you can see, we get a much clearer representation of our resulting polygons, the topology generated by our OVDB mesher. Okay, so that's looking good. The density of those polygons is looking good. It's coarse enough and low res enough that it'll be nice and fast to simulate with XplosaFX, but it's a good approximation still of our wick. And if I actually reveal that wick, you'll see that we have a good match in terms of the volume. Of course, we have these very fine fiber details coming off of our wick here. However, we don't need to worry about that because this is just an approximation, and we won't be seeing this. It will be hidden from our render, and therefore the approximation, the amount of detail we have here is appropriate. So because we're happy with that, let's actually create a duplicate. I'm going to right click and I'm going to say current state to object. I could just make it editable, that would turn it into a polygon mesh as well, but I'm actually going to go for current state to object. I'm going to deactivate our OpenVDB mesher, and we always have that if we ever needed to come back and tweak some settings. It's recommended that you create a duplicate. Okay, so we've got our mesh here, our OVDB mesher. This is actually our wick proxy, so it's a wick, and then I can do wick proxy, and it's a source as well. So let's put it next to the wick. And let's now tell XplosioFX that this wick is a source. We need to right click, xParticles tags, and add an XplosioFX source tag. Okay, let's zoom back out a bit. And let's see our resulting simulation. So as you can see, our wick proxy is doing its job. It's adding heat, it's adding fuel, and we are getting some kind of flame coming off our wick. But as you can see, there's a couple of problems here. Now, it's not very dense at the moment, so at the moment it's just utilizing the interior voxels. So only voxels that are fully within inside our geometry here will actually be calculating. And of course, our geometry here is quite thin. It's actually only around about 1.5 diameter, so it's quite a thin, it's not very thick. So that would barely be one voxel. So what we're going to do is we're going to change it from a volumetric source, a solid source, to a surface. So I'm going to do that by unchecking the solid, and there we go. And now we're seeing a lot more of the fuel and heat being added, and we're getting that nice burning. But the second problem is the fact that our fuel is all the way down inside our candle. Now, technically that's true, of course, because the candle wax is our fuel. However, what's really happening here is that when you light this, of course, it's melting the wax, creating these gases, and then the wick is pulling up that melted gas into itself, which then vaporizes and creates that simulation. It's not from all the way inside the center of our candle. So what we'll need to do is we'll need to reduce our proxy's vertical size, and we're going to do that by just removing the lower half of it, essentially. So let's hide our other wick, our visual wick, and let's go to polygon mode, and we can just grab a live selection tool and make sure only visible is deactivated. And I'm going to go pretty much halfway down, like here. And you can see I've created this sort of collar here. Then we'll use U and F, which is the fill selection. Hold Shift, select that bottom half, and then backspace to clear that out. And now if we put our wick back on, you'll see that we're around about halfway down, a bit higher than halfway down. And what I want to do is I don't want it to just suddenly have it stop off, so I'll have it taper down a little bit as well, so it kind of tucks in a little bit here and here. And what we'll do is we'll use a brush for that. So hit M and then C, that's a shortcut. And then make sure the brush is in smooth mode. And then you might want to reduce the strength down a touch. And there you go. You can see we can reshape our source. And obviously the shape of the source will dictate the look of our flame. In this case, because we've got quite a diffuse flame, it won't have such a huge impact. However, it's worth knowing these processes if you ever need to do a different shape source, of course. So there we go, there's our source, it's prepared, and if I hit play now, you'll see that we are getting emission of our fluid channels. So we've got our fuel and our temperature, it's mixing, and we're getting that smoke generation and all the resulting motion. However, as you can see, the shape of it isn't really looking like a candle flame. You can see right now it's quite a thin flame. It's got a lot of smoke, and it's actually quite detailed for a candle flame. A candle flame is much softer and more diffuse until it gets up to the top, of course, where we'll get that wispy smoke. So on this playthrough, we're actually going to increase the pressure around our wick here, and we can do that in the source tag. And I'm going to jump it all the way up to 200, and you'll see immediately our flame gets much bigger. And if we go back to frame 0, you can see that it's an appropriate size sort of base of our flame. Not how it develops, but at the base of our flame, it's sort of an appropriate size for this wick and this candle. Now, of course, the pressure is simply adding these new velocities. It's pushing away from our source, our proxy source, into areas of lower pressure, which is actually causing our fuel and our heat and other properties to advect away from our wick, which is actually creating this much larger flame that we're seeing. Now, we're also seeing inside that flame quite chaotic motion, and some of that is coming from our source tag in the form of this curl parameter. I'm going to drop that to 0, and that just means that we're not adding any extra noise, any extra random velocities to our simulation. We want it to be quite a calm flame. We want it to be quite a gentle candle flame. So I've turned that off, but of course we're getting all our vorticing and turbulence still from our XplosioFX object and the simulation settings themselves. And that's what we're going to look at next. We're going to develop the look of this flame. Just before we do that though, if I zoom right out, you'll see that we're actually calculating and solving smoke all the way up here. And if you think about it, we're only developing our flame down here, and yet we're still solving and calculating all of these voxels up in the top half of our container. So often in production, we can temporarily move our XplosioFX object. We can reduce its size. So let's go to the solver tab, and you can see our size is currently set to 200. Let's drop it all the way down to say 120, and let's move it down in Y. And what this means is that we're not going to solve anything that we don't need to up here. And once we go to return to developing the smoke, we can actually resize that and make sure it's appropriate then. We can keep moving it around. It's no problem to do so. But like I said, we're going to just focus on the flame. So we can actually just completely turn off our smoke solve for now. So if I hit play, go back to 0, you'll see now that we're just seeing our burning fuel and it's moving upwards in our container where it won't solve anywhere above there, of course. Okay, so our flame is a pretty classic looking flame. It's got these kind of licks happening, but a candle flame is much smoother than that. It's more diffuse. It comes to a point eventually, a little bit like this, but it's much more diffuse and less aggressive than the one we're seeing here. And a lot of that is from the diffusion of the fuel. So what we'll do is we'll jump to the XplosioFX object, simulation tab, and you'll see we have settings in here for diffusion and dissipation. And the first one we'll look at is the diffusion. Now the diffusion we can think of as the rate at which these channels, so these properties such as smoke, heat and fuel, how fast they diffuse into their neighboring voxels. So if you think about it in the real world, if you have a high density to a low density, you get a density gradient and you'll have the higher density molecules moving from there into the lower density. And this is emulating that effect. So if we want to increase the rate at which those molecules diffuse, and in our case, properties diffuse into their neighboring voxels, we can increase these values here. So let's increase those. I'm going to go for quite a high value in the fuel, because of course we're viewing the fuel at the moment. We're going to add diffusion to each channel, but first of all, we're going to start with our fuel diffusion. And you can see here, at a value of 30, it's diffusing quite significantly. So our fuel value is diffusing very quickly and we're getting quite a small flame. And we're also losing quite a lot of our detail in our flame there as well. However, it is getting pretty close to how a candle flame looks. It's sticking down pretty close to where the wick is. And we're getting this interesting variation where it's burning at different rates. And we're getting sort of a slight flickering of that flame. However, like I said, it's way too diffuse. So let's drop that back down and let's drop it down to 15. And there we go. We're starting to get a much more candle-like flame. And our flame is also managing to reach higher up. Our fuel is managing to reach higher up, of course, because we are diffusing it slower. Now I could go back to our source tag here and I could add more fuel to compensate for this process. So I could just double the amount of fuel and you'll see that we get a much larger flame and you get this nice waviness at the top here. And so we're kind of balancing out here the fact that we're diffusing, we're moving fuel away from the original source and then it's diffusing through our simulation. And then if I increase the amount that we actually add to the sim, that actually overall will increase the size of our flame and we'll get a much larger flame. Okay, we can also do that with heat. So let's go back to our XplosioFX object and the heat diffusion parameter. Let's increase this a smaller amount. Let's go to 5. There we go. And now our fuel and our heat is diffusing. The problem we're seeing, we're getting a really large flame. You remember I just added a lot more fuel to our simulation. Now I left it high because I actually want to dissipate that fuel as well as diffuse it. Now, obviously this is looking like quite an aggressive candle flame, quite a large one. However, the overall diffusion look is actually working quite well for us here. So I'm going to go down here and I'm going to add one more value and it's into our viscosity. Now, This is a good way to calm down frenetic motion in a simulation. It's diffusing and allowing the velocities to diffuse across just as we are with the heat and fuel channels here. So I'm going to increase that to 2, and that'll just calm our flame down a bit more. And then we're going to look at the dissipation. This is where we're going to actually remove our fuel from our simulation and of course our smoke later on. So on this next run, we'll test that out by increasing our fuel dissipation. So let's turn it to 4. And you'll see all of a sudden our fuel amount has decreased significantly over time. So what's happening here is that we are decreasing the amount of fuel. We are dissipating the fuel by 4 fuel units per second. So over a second, you're essentially removing fuel at a higher rate than 1 per second. So it will, in a quarter of a second, it would remove all of the fuel in 1 voxel. Now, of course, we're re-adding that fuel from our source. So there's this balance here where we're adding some, it's being dissipated, and then that cycle continues. And we get this much smaller flame, and it's actually a bit more realistic in terms of a candle flame. This is too high though. I don't want our dissipation to be quite so much. And I'm actually going to change that to a dissipation value of 2. And you can see now we've got a pretty reasonably good looking candle flame going. And I'm going to now dissipate the heat. Now the heat is, of course, you can see the adaptive bounds is all the way up here because our heat is all the way up here as well. Now dissipating the heat, if I dissipate it too much, let's go really high, you'll see it dissipates a lot. And at this point, we are actually no longer igniting our fuel, even though it's in our viewport here. This is unignited fuel, and therefore it is it's not burning. We're not getting any buoyancy, and it's not looking very realistic. So we're not going to dissipate it that much. In fact, we're going to dissipate it just below 1. So one unit of heat every second. A bit less than that is going to be removed from our voxels, and we're going to get some decay of that heat. Okay, so the other thing is to take a look at our smoke, of course, because we've now set up our flame here. So let's actually turn our smoke back on, and let's see what's happening. And now you can see our smoke is kind of taking over the sim there. We're actually getting a bit too much of it. So what I'm going to do is I'm going to go to the simulation tab, and there's a couple of things we're going to need to change. So first of all, let's have our smoke dissipate some more. So I'm just going to have it dissipate a small amount. Any one voxel can only contain a full 1 value of smoke, so 1 unit of smoke. So with this one, the dissipation value, it keeps it nice and thin at the top here. It's quite sensitive, so it'll actually kill off our smoke pretty quickly if I increase it too high. But there we go, we're seeing some nice wispy smoke at the top there. However, what we're not seeing here is that there is a balance between the amount of fuel and the amount of heat that we are adding to this simulation that is generating our smoke. Of course, what's happening is we are adding those two properties, the fuel and the heat, and then the burn model is taking over that. So what we have right now in the tag is we have this large amount of fuel and then a smaller amount of heat being added to each of the voxels. Now, we need to actually trigger an ignition heat, and currently that ignition heat is well within that threshold. We've got a large amount of heat being added. However, if we wanted to reduce the amount of smoke here, we can do it in a few different ways, but one of the ways is to actually increase the ignition heat. So I'm going to increase that to 0.7. So now only heat over the value of 0.7 will actually burn our fuel. It will actually ignite our fuel, causing a reaction. And there we go. We can actually see that we are getting some burning occurring. We're actually getting no smoke produced because we're perhaps dissipating it too fast. However, there's not enough heat in our simulation here to actually mix with our fuel to generate that smoke. So only some of this is actually being burnt. So what I'm going to do is I'm going to go to our tag again, and I'm going to increase the amount of heat as well. And there we go. You can see it's actually causing our flame to lift up. And there we go, we're getting this wispy smoke. Now this is one of the keys to getting wispy smoke, is the balance between these two things, the heat, the fuel. And then a third thing, of course, is our simulation settings here, where we're balancing it with our ignition heat. And then the actual look and shape of that smoke we can develop over here. And you can see that dissipation value is working well. If I turn it down, you'll see we get more smoke. But I want it to actually be really thin and really wispy, so I'm going to actually return that to 0.1. And there we go, we have our thinned out wispy smoke again. And this is really close to the final product. This is getting pretty close to the actual candle flame that we want and the wispy smoke. There are a couple more things to tweak, and one of those is actually the buoyancy. Now, currently, if I open the buoyancy panel, you can see our smoke, heat, and fuel buoyancies are all set to their defaults. Now, they're mostly okay. What I want to do is I actually want to increase or decrease the buoyancy of our smoke, so that when we extinguish our flame, the smoke wants to actually drop down, and it'll actually cause it to sort of linger as it balances out with the heat. And the other one there is actually the fuel. Now, if you look at the bottom of our flame here, you'll see it sagging occasionally. And what's happening there is actually the unburnt fuel obviously has there's not much temperature around here, not much heat, and therefore it actually sags and drops down. I want the fuel to behave as though it's sort of vaporized paraffin, and therefore it's much closer to air, the density of air, and therefore it would be pretty neutrally buoyant. I'm going to actually make it slightly negative, just -5. And that's calmed down that sagging sort of at the bottom there, and it's looking much nicer. Okay, so the last thing we're going to do here is actually we're going to add some more turbulence to our flame. Now, the turbulence strength inside our buoyancy panel here, if I increase it to 30%, this will get extremely erratic, as if there's a lot of turbulent motion near the flame, and it'll actually get a bit out of hand. And in fact, it's struggling to even mix the fuel and heat to generate our smoke. So I actually don't want to do that too high. I want to make sure that it's somewhere in the middle or a bit lower. And there we go. 10% looks quite nice, and we'll still get some smoke from this. There we go. I really like the sort of the flicks of smoke that we're getting, and the candle flame itself is looking really nice. And what we can do with that candle flame, in fact, now that we've dialed in all of our simulation settings, is actually play with the display. So let's find a nice moment where we have some nice fuel and also a bit of the smoke that we can play around with the settings for. And there we go, that'll do. We've got this sort of nice classic candle flame shape and a touch of the smoke up there as well. Let's go to our display tab, and we're going to focus mostly on the fuel because that is the representation that we're seeing here, and it's burning fuel, of course, in our scenario, and it's our candle flame. So it's set to default as black body, the color mode here, and that's giving us this nice looking natural tone. However, there's a disadvantage of the black body gradient, and that's that I cannot tweak, I cannot add any colors that aren't in the black body gradient here. And I actually want to add a blue color because a lot of the paraffin wax candles will give off a blue color flame. That's actually nothing to do with black body luminescence there. It's another process. So what we're going to do is we're going to change it to a manual gradient, and you'll see we get a preset curve that's already in here, and then we get this rather dull looking flame. And the reason it's a dull looking flame is that there's a couple of reasons. One is that the fuel opacity is set to quite dark. And if you look here, the fuel opacity, if we consider that the amount of fuel at this end is 0 and at the other end is 1. So full fuel will actually be quite opaque, and then no fuel will also be opaque, but in between that, we actually have this gradient that has some value, and it's got a brightness value of 30%. If I set this to 100%, you'll see our flame becomes much thicker in the viewport here. We can still see our wick, and the reason we can see our wick is because our fuel that's immediately added is not burning, and therefore it would not have any, it would not be opaque, it would not have any color to it yet, and therefore we can make it transparent. So we're making the core of our knots here of our fluid transparent. So let's make that like so. I'm also going to tighten these up, so I'm going to make it slightly crisper so that we go from a much softer to a fairly sharp area on the interior here. That'll do for now. And what we'll do here with the gradient is we'll add our custom colors. So as you can see, as I move these colors around, they apply to different parts of our gradient. Now I want to have a blue on the outside here because this is actually where the hottest part of our flame is. And this is going to be a blue color. So let's just tweak that and add that blue color in like so. There we go. And now you can see the outside of our flame has this blue color. And I'll balance these out, but I'm going to add in another middle knot. And then I'm going to actually make the core, I'm going to make the core no color at all. So I'm going to make that black. And you can see now it makes our interior much darker and more transparent as well, like so. And then I want some reds as well. So of course we've got this kind of yellow that's not particularly natural looking. So let's make that orange. And also let's desaturate it a touch because I'm going to increase the brightness value. So let's increase the brightness value. And the advantage of using the gradient here, you can see it's quite dull looking at the moment. I can actually overdrive these colors just like you can in the color channel of a C4D material. And there you go. As I increase that, so we're at 300% there, and it's causing the much brighter looking flame. I'm going to go even more than that. I'm going to go to 500%. And then I'm actually going to make sure we've got some more reds in here. So let's drop a red in between here. Nice high saturation one. And you can see now we're getting a nice looking candle flame. We can tweak this one again. And you can see as I desaturate it, if you look at the gradient, it actually goes out to white. So you may need to make sure that you're not at full saturation, just below that, and that will allow our exposing, our increasing of the brightness to color our flame nicer. Okay, so we could tweak the knots here if we want to bring more reds in, but I'm pretty happy with that, and that's looking really nice. Now the smoke I'm going to leave at default, but just to demonstrate, we can actually tweak that as well. Now I want it to look quite low density, so our transparencies are looking pretty good at the moment. We could add some color to this if you wanted to. Maybe we're doing some kind of magic spells and you can have it generate a color smoke like so. But for now, I'm going to leave that one at default because I like the wispiness. Now let's just test that out, playing it back. And that's looking really nice overall. And now I've tweaked the color and things. I could go back and I could have always increased or decrease the transparencies in these, or increase the transparencies. Like the smoke right now is quite, well, let's put it at 30%. So it's even lighter now, even more transparent, of course. And then our fuel transparency has already been dealt with. That's at 100%. And there we go. Now, before we move on to our animated candle, I'm going to actually take advantage of the fact that it's static for the moment to demonstrate a really cool technique which can transfer fuel data and properties to the surface or the vertices of another object. As we play, of course, a candle flame, if you put an object in between, obviously it's going to get very hot, but also it's going to leave a lot of soot on that surface. It's very common for candle flames to leave soot on the surface that they are intercepted by. And what we're going to do is we're going to take a surface, and I've actually got one hidden at the bottom of our scene. It's inside these nulls, and we've got this object here called the 2x8 plank, and surely by the name you can guess what this actually is. And it's actually a broken piece of that plank. And let's change our view so that it's back to a non-line view. There we go. And you can see this is just a sculpted chunk of wood sort of broken off that has a bunch of sort of viewport materials on them. And in those viewport materials, we're using a lot of these vertex maps that we have on here already. The one that we're interested in here is this one here called Soot. Now this has just been painted on here, but if I go to our viewport material wood burn, there's another clue. And I put that over there like so. Go into our fusion material, our fusion shader, and then in the mask channel, I'm just going to drag that soot into here. And you'll see what it does is it acts as a mask between two shaders. One is this dark noise, which is sort of like our sooty material, and then the other one is our wood. Okay, so what I want to do is I actually want to generate that map dynamically from our XplosioFX simulation, and that's where the really cool stuff comes in. So I'm going to position this in such a way that the flame will rake up the front of it, and we'll get the smoke moving up there as well. And let's have it start on the corner like so. And there we go. So I've positioned it, and it'll move up and it'll actually propagate across that surface. Now, what we need to do now, of course, is we need to add that xpVertexMap object, which is going to generate our vertex map. And we can find that in our utilities drop down in the xParticles menu. And there we go, we've got our xpVertexMap. Now this expects an object in the object field here, and it's the one that we want the vertex map on. So of course it's our plank. And we've dropped that in, and now it's got this default layer of polygons. Now we can leave that on there for now, but we're just going to leave it there as sort of a base layer. And you'll see that we've added a VertexMap tag. Now I want to change the name of this, and we go into our VertexMap object, and you can see it's called VM source. I'm going to change it from VM source to VM source _ soot. And you'll see it actually added another tag. So I'm going to delete the other one. I'm going to delete the painted soot, and I'm just going to work with this VM source soot. So this is now the new vertex map that's being generated by this object. And of course now, this is where we need to make sure that XplosioFX is the source for our layer. So we're going to add a new layer, and it's the XplosioFX layer at the top there. And you'll see it's now added. And what we want to do is we want to make sure that the XplosioFX object is connected in this XplosioFX object field. So we can just pick that like so, and that's now connected up. And if I hit play now, and I'm going to hide our XplosioFX object, of course, so that we can see underneath, you'll see that we're actually getting XplosioFX data transferred to the vertices of our low poly plank object here. And you can see it kind of changing, and you'll notice that it's actually adding the information, and then it's actually completely overwriting at the next frame. So it's setting new information each frame. So what we actually wanted to do is deposit that vertex information and then move on. And we can do that using our fade then add blending mode. Let's try that again. And there we go. Now we're adding soot, and it's actually fading away over time. We don't want it to fade at all. We just want it to be added, and then it's on there until someone maybe comes and cleans it off. And there we go. Now it's full opacity, and it's propagating up our plank object. Now let's go to our viewport material, and now let's connect up, instead of our soot painted, let's drag our VM source soot in there as well. We also have a vertex map slot in here for the reflections as well. And you can see immediately in our viewport, that was showing a really nice blackening of the wood here, and that's creating this burning effect. Now you'll notice that it's not propagating up all the way up here, and the reason for that is that our object is not actually colliding with our simulation. So if we show this, you'll see our simulation is simply going through the wood here. Now what we want to do is we want to make this a collider with the simulation. So I'm going to right click it, and we're going to add the xpExplosiaFX collider tag. And then I'm just simply going to play that again. Now it'll take longer to simulate, of course, because we've got a lot more polygons to calculate and a lot more polygons to collide with and create the vertex information with. And there we go. So it's now colliding, and we're getting it propagating up the surface. However, as the temperature makes contact with those vertices, it transfers to a vertex map, which we're then driving this soot shader, and we're getting this really awesome looking effect. Okay, so that effect is actually occurring obviously over a solve, but what's happening in reality is that as soon as I move this object, the vertex map is still active, this xpVertexMap generator. If I move this, you'll see it's live. So as I move it through the smoke and the fluid, so wherever there's temperature, I'm adding more vertex information. So that's a really cool way of burning objects or transferring vertex information onto those objects. And of course, we could do all sorts of things with those vertex maps, and I'll leave that up to you to play around with. Okay, so let's deactivate that. I'm going to turn off our vertex map object. I'll put it into our hierarchy so that we can use it later on if we ever wanted to. And I'll put our plank in our sources and colliders, but I'll hide it and deactivate it. There we go. And like I said, let's take a look now at the actual animation. I'm going to turn our XplosioFX object off for the moment because I want to know how big our XplosioFX container is. And I could just take a guess. However, whilst it's simulating, that can obviously be a bit slow. So I'm going to turn that off for now. I'm going to hit play. And of course, we have no animation. So we need to make our candle holder on frame 0 a child of our animation. We need to reveal that as well. And then if we hit play, we'll go back to the point where we had that animation. Now it's parented, and there you go. So it's moving around. Now, like I said, we don't know the bounds of our simulation here. We know roughly where it's supposed to be, but positioning our XplosioFX to make sure we contain all of that motion is going to be quite tricky. So I actually use a little trick which utilizes a trail object. And if we go up to our proxy source here, our wick, and we actually center the axis on this piece of geometry, what I can do is go to mesh, axis, and then I can go axis center to, and then all points. So now we've got an object that is referencing this point up here. And what I'm going to do with that is actually use it as a source for our trail object. Now, I'm going to go to the generators tabs and we can add an xpTrail object. And it's at the bottom there, xpTrail. And something that the xpTrail object can do is that it can actually not only trace particles, but it can trace objects, and it can trace the vertices of those objects. It can do all sorts of cool stuff, polygon centers and that kind of thing. I just want it to track the axis of our wick proxy source object here. So I'm going to have it track the source. And now when I hit play, when we get our animation, we'll get a trail following our wick. So now we've got a much better idea of where our simulation is going to be. And once it stops down here and spins back round, I'm going to press pause. And there we go. Now we have a trail, which is essentially exactly the path of our animation and of our wick, of course. And I'm going to make that editable so that it's permanently in the viewport here. And then I'm going to use that to help resize our XplosionFX solver. So let's turn that back on and we can see our bounds here. And we could use our views here. So we could go hit F5 and we'll see all of our views side by side. And there we go. We can include that part there, like so. And remember, we're going to be swinging this candle around, so our fluid isn't just going to stick to exactly that line. It's going to be lifting up with the buoyancy, and the velocity is obviously going to kick it off in all sorts of directions. So we're positioning it in a way that it will now contain our whole solve. And of course, the adaptive bounds will also keep things in check as well. I'm going to give it a bit more headroom, like so. And there we go. Let's see now when I animate in this perspective viewport. And as you can see, it's encapsulating our whole spline, our trail, which is the path, of course, of our wick. So let's now run a test that we can see actually the candle flame being solved. So it's all active and ready to go. So let's hit play and we'll see our candle start solving. Let's turn our bounding box, our adaptive bounds off for the moment, so that we can just see our flame and the solve. And there we go. We get our lifting moment, and then our flame is being dragged through, and then we're getting a nice bit of smoke coming off that. And there we go. This is creating some really interesting velocities here where we're getting the motion, we're getting the flicked smoke, so we're getting the wispiness of the smoke really shown off here. And obviously the flame is being dragged around, the wick is being dragged around, leaving more fuel, of course, and giving us that larger flame. That's looking great. There we go. We're getting this big swing round at the end here. And it's going to come round to a stop. And this is looking great. Now, something you'll notice at the beginning of this simulation was that as we lifted it up, it actually collided, or actually did not collide. It went through the bottom of the candle, or sorry, the top of the candle wax here. And you can see there are some other moments there that it might have been going through as well. And we're going to fix that. And we're also going to create our snuffing out moment at the end here. And we're going to do that simply by animating down our fuel and temperature parameters. So we'll do that at that moment. But first of all, let's deal with that collider. And let's just grab our candle wax in the viewport here. And you can see it's called candle wax. It's a polygonal object. And I'm actually going to create a duplicate because I want to actually cut part of it off. And I don't want to affect the original mesh. So I'm going to copy. You can just do Control-C and Control-V. Or you can use the edit menu there. And I'm just going to paste it back to the top of the hierarchy. Hide our original sim there. And let's delete those materials and vertex map. And we can also do a quick lines display because we need to be able to see the polygons themselves this time. And now if I go to polygon mode, you'll see that we actually have only sort of 36,000 polygons here. So it's not the most dense mesh you'll ever have seen. However, we only want our collision. We only need our collision to occur at the top part of our wax here. So we're going to cut away the bottom part and actually reduce the polygon count down quite significantly. So to cut, we're obviously going to use a cut tool, which is the shortcut K. And then you'll see we have an option between plane cut, line cut, loop cut, path cut. And we're going to actually use a plane cut. And I'm going to set it to a local cut. or you could do local or world, in fact, because this is obviously aligned to our world axis upwards. And if I hover over right now, you'll see that our local cut will actually be occurring on the actual mesh on the XY axis. We want it to be the XZ, which is obviously across. And there we go, like so. And now I've currently got it set to cut all. I actually want it to remove the lower part. So I'm going to have it remove part B. And let's put it about there. And there we go. Now it's removed most of it. It's done its best job that it could, but there are some polygon islands that it's ignored because they were not connected to this original mesh. So we need to actually just remove those. And what we could do is we could select that one poly, or we could just double click and it'll select all the connected polygons. And then we just run the command U and then I. It inverts the selection, backspace, which clears the islands that we don't want. Okay, so we've reduced the polygon count really significantly. We're now down to 3,900 instead of 39,000 or 30,000. And what we're going to do is we're going to seal the base part, and we're going to use the close polygon hole for that. So M and then D, you can see there, D is close polygon hole. If I move in closer, you'll see that we get this prompt. I just need to click and we'll get that sealed off like so. Now, it's very crude geometry, but remember, we don't need it to be very pretty looking because we're going to be hiding it from the viewport anyway. And now, even though it's at 4,000 polygons now, which is still quite low, we could get it even lower than that. And what we'll do is we will drop it inside a polygon reduction object. Now I'm holding Alt whilst I drop this in because I've got my candle wax object selected, and that will make our candle wax a child. And then very quickly you saw that polygon reduction occurred, and we get this very crude but still indicative of that mesh representation. And I could change the amount. In fact, it's a little bit harsh, so I'm going to drop it down like so until we've got about 600 polygons. Okay, so let's make that editable. And that is now our collider mesh. So this is now our candle wax proxy. It's not a source, it's a collider. So let's name it so. And to make it a collider, to communicate that fact with the XplosioFX object, we need to add the collider tag. So right click, xparticles tags, XplosioFX collider. And then what we're going to do is we're going to grab that collider and we're going to make sure that it's in the hierarchy with our animation null. And we'll put it back next to our candle. You'll see our candle wax. And of course, we had it hidden. So let's make sure it's visible and showing. And you can see there, it's in the correct position and it's sitting there nicely with our candle wax visual representation. So let's hide that now. Let's zoom out and let's see how our resulting simulation looks. In fact, let's focus on the area around the bottom of the candle here. So we'll let it play. Now remember, the candle gets lifted up around about the 60th frame, so we'll need to let it calculate up to that point. And then we'll sort of slow down and we'll go frame by frame to ensure that our collider is working correctly. And here we go. Here's that lift moment. If I pause, you'll see it's now causing a bit of a bow wave because the colliders in Explosia actually create sort of a pressure change. And you can see now that this is actually pushing up our flame as it lifts up instead of letting it intersect with our candle wax. And now we're getting a much more accurate simulation. That's looking really cool. And that's our collider for our candle. This will also impart some velocity into our simulation as well. And on that actually, we should make note of the fact that currently our source tag, let's go to our source, you'll see tag, we actually are adding no velocity from our source object. And we want to do that. So I'm going to add 100% velocity into our source. And also it's already set that way in our collider tag as well. So that's fine. And now when I hit play, we get a slightly different look to our sim. And what's happening now is that the motion, the velocities of our wick proxy object will be transferred into the sim, which means when it gets to those edges, those moments where it changes direction, we'll get a really nice motion in our flame. Here we go. Lifting up our flame. We're getting that really nice trailing flame there. And then when it gets to these moments of sort of halting in the corner here, we'll actually get it flicking to the other direction. There we go. If I pause there actually and look up, you'll see that it's releasing a bit of that wispy smoke as well, which is really nice. And there we go. Okay, so now we've sorted out the collisions, we can take a look at the final moment, which is the moment where our candle snuffs out. And of course, that's much later on in the timeline. If I want to start animating parameters later on in the timeline and then testing it with xplosaFX, if I just jumped to that point, which is around about the 300 frame mark, it would actually start to try and calculate up to that point. It would also give quite an inaccurate calculation. So what I'm going to do is I'm going to turn off xplosaFX and I'm going to move up to the point. If we look at our candle, go to the animation, you can see our keyframes here. These last two keyframes are that rotation moment, and that's the moment where I want the flame to snuff out. So currently frame 30 to frame 50, I'm going to have them animate down, and I'm going to start with the fuel, only the fuel to start with, and then I'm going to frame 50 and I'm going to go to 0. And then from that point on, I'm actually going to have the heat decay down for the next 20 frames and also the pressure. In fact, actually the pressure I'm going to have going over the whole 40 frame range. So frame 370, let's animate the heat down now. So by this point, we've got no heat or fuel being added to our simulation and our pressure is still at 200. Now, if I go back to that 330 frame, let's add a keyframe for pressure. And let's go all the way to the end at 370. And I'm just going to leave it at its default of 10. So it's sort of a natural amount of pressure just to give it a nice look. So now we've got this moment where our xplosaFX source object, source tag here, animates down and we'll have no more being added to the sim. We should also add a few more frames. So let's just add a few more frames just to make sure that all of our smoke has vanished from our simulation. And let's go back up to our xplosaFX object. Let's go to, I don't know, let's go for around 280. Hit play, activate our xplosaFX object and hit play. And there you go. So we're now solving from much later on in the sim. It's not going to be exactly the same as if we played the whole simulation through, but it's going to give us a very good approximation. And it'll give us a good idea of this snuffing out moment here. So here's our fuel going down. So we've got no more fuel, and as the fuel decreases, but the heat remains higher, we can burn more of that fuel and we get more smoke, and then eventually it just snuffs out to that moment there. So that's excellent. That's now going to loop back round again, and we'll get this continuous loop of our ignition of our candle flame here. We get the wispy smoke and all that stuff, and it looks great. Now, one thing to note is that now that we've created this simulation, we've got pretty much the start to end completely done. We can actually increase the resolution of our sim. Now, there is a risk when we do this that it's going to change the look of our candle. However, I've tested these parameters out and they look good at a lower resolution. So you can see the voxel size currently is set to 1. I'm going to drop it just down by 25% to 0.75. Now that might not sound a lot, but if we look at our estimated voxels and our estimated full memory size required for the whole container to be filled, you'll see when I go to 0.75, it jumps significantly. So it's not just a small increase, it's actually a dramatic increase. It's more than doubling the number of voxels there. And let's hit play now. And we'll see our flame is looking pretty similar to how we had it before. It's looking nice and crisp. And we should see a bit more detail come through from that turbulence. There we go. And that is looking excellent. Okay, so now we're going to cache this so that we can actually see it playing back in closer to real time. And then we'll be able to render that to a hardware preview as well. So I'm going to do that now. Let's cache our simulation. And we need to do that by going to our Utilities tab, adding an xpCache object, and then if you have the hard disk space and you have nice fast SSDs that you're caching to, you can actually turn compress cache on build off to get a faster solve. I'm going to do that for now because I have enough hard disk space and they're fast. And we're going to build the cache and then we're going to come back and review that cache. Okay, and that's now cached. And if we go down to the bottom of our cache object, we get some data. And we've cached out those full 450 frames. The disk space used total is 10.68 gigabytes, and the time to complete was 7 minutes and 14 seconds. So not too bad all overall. And if I hit play, we get a nice playback, especially early on. Obviously, as the adaptive bounds expands, it'll get a little slower, but we're getting we're not having to solve anything here, so it's getting a nice playback. Let me actually hide that adaptive bounds. This moment here where we actually move from the back to the front really fast, that's going to be the moment where we have the most information to solve. Let's turn our adaptive bounds off, and even let's turn our outer bounds so we get a nice clean looking simulation. And I can scrub through as well. So we get that nice sweeping moment, and then there's this moment where it comes back around to settle down, like so. And then this is the key. We need to see our snuffing out moment in real time, or close to real time, and there we go. So you can see that our wick actually has a bit of a material attached to it, of course, and it has that glow. So we're going to do two things here. We're going to hide our proxy, our source proxy, like so. And we're also going to time our animation of our heating up here by going to the wick material. You'll see I've got a keyframe on it already, but I'm going to remove those. And I'm going to start at 0 so that we have no brightness. And then as our flame increases and gets warmer, we'll increase that to that 200%. So again, I'm overdriving a luminance channel here. There we go, that's looking quite nice. And then here I'm going to have it fade away a lot slower towards the end. So as it snuffs out, about this point we're going to start fading it. And I'm going to fade it over a lot longer time. Perhaps, let's see what this looks like. There we go. It's probably a bit too long because if you think about it, it's going to have a lot of heat inside it, but we don't want it to be enough to reignite our sim. Obviously, that's only visual. And there we go. So we've now got our really cool candle flame and wispy smoke loop going on, and it really looks great, especially at those moments where it changes direction, and you can see that smoke there looking really nice. Okay, so that completes our candle flame and wispy smoke project. We've learned there how to create source geometry out of a more complicated mesh, and also the same with some colliders. We've learned how to shape a flame to make it look like a candle flame, especially using our diffusion and dissipation settings. And we've learned how to balance our fuel and heat with our burning model and our ignition temperature to create that wispy smoke. And then we've taken that resulting simulation and had it transfer vertex weight to a piece of geometry to create a soot effect in the material. And then finally, we animated our candle, we animated our extinguishing, and then we cached the resulting simulation.